Hi everyone. So finally here we are. I remember I promised you concerning LR parsing that I'll make a recording for you. A number of you have been asking me about LR parsing. So here is what we have. I extracted from the previous slide, from the normal class slide, I extracted the LR parsing part such that I can make direct explanation without going through 34 slides. So again, if you can remember, we said that there is this guy who told us that there is a way we can do bottom-up parsing, and that if we can keep the history of our input token and the state that got them parsed, we can actually make future parses. So we said an example of such approach is the reduce shift algorithm. So in the reduce shift algorithm, we have a reduce action and then we have a shift action. So this is the definition of reduce. Is the action of replacing the handle on the top of the pass stack with its corresponding left-hand side. So you would have seen this, and probably some of you are still wondering why this is like this. It doesn't look normal. Yes, it's not normal because it's not the normal rule that you're familiar with. It's not the derivation rule. This is a reduce rule. So what it means is that whenever you have E plus T must have been produced by E. And it goes like that down. So if you have T in an input that you are parsing, it means that the T could have been produced or must have been produced by E. So what you are doing now is that you are replacing the right-hand side with the corresponding left-hand side. So if you have an expression as this now, so we look in this reduce rule and we get the right rule that can reduce it. So if we try to parse ID, what it means is that we parse ID using rule 6. And in reduce rule 6, it tells us that ID was produced by the left-hand side F. So subsequently, what we should expect to have is reduce rule 4, which tells us that F actually was produced by T. So we take that backward step of building the parse tree, not from the root now, but from the bottom. If you remember, this is bottom-up parsing. So F is produced by T, and again, if we go up, we find that T is produced by E. The next thing we need is E produces E plus T. But at this point, we can't use only E since we still need the plus and the T. So this actually is the idea behind LR parsing's reduce algorithm. Now let's go to the shift part. The shift part is the action of moving the next token to the top of the parse stack. So what the shift means is this, that you take the next token, after removing this, you take the next token to the top of the parse stack. That is shift. So you shift what is here to the top of the parse stack, and then at the same time you put the state. You put the state of execution at the top of the parse stack. So the idea is simple, and here is the table you are familiar with in the class. This is the parse table. The left side is the action part, and the right side is the go-to part. So the action is what you will do based on the intersection of the state here and then the ID that you have, the ID, the terminal that you have. These are the non-terminals, while they also intersect with the state. So for this, you select go-to part from here. Also, you are familiar with this. So let's just go straight to the explanation. For the explanation, I already found a way to squeeze all three of them, since we will need the reduce rules, we will need the parse table, and also we need the table for the stack input and action. So I found a way to squeeze them all together. So this is a warning. Do not do this in examination. The rules will be given to you. These rules are not meant to be on this table. I put this here because I don't want us to go back and forth in slides. Please don't get things messed up. And if you observe, I deliberately didn't leave them on one row. I deliberately merged all the rows together so that you don't have any reason to put them on any row here. Please don't put them on rows here in the examination if you find this question. All right, so let's start. If you go back to our regular class slide, you remember that we said that at the start, the stack is empty. So we have state 0. That's why the stack is empty. Here is the input. Also, if you go back to the previous slide, actually, this is the input to be parsed. And the input is ID plus ID times ID. If you see closely, that the dollar sign is there, but I made it a bit faded. The reason for this is that dollar sign is not part of what you want to parse. Dollar sign is just a sign that you have reached the end of input tokens. All right, so if you look here, we have the dollar sign here, but even when we end, we still have the dollar sign because the dollar sign is not what we are parsing. It's just there. So I think with that, you're already armed with enough information for us to begin the explanation. So we start and the stack is empty. All we have is state 0. So how do we parse id plus id times id? The first thing is that we get state 0 and the first token id. So we said that the left is the state, and this place holds the terminals and then the non-terminals. So id terminal is here. The intersection of state 0 and id gives us S5. S5 means we are doing the shift algorithm now. We are doing the shift part of the shift reduce. And what did we say the shift means? It means take the current token and put it on the stack. So we take ID and then we put it on the stack. If you look at the next line, ID is gone. So we take ID, we put it on the stack. Now, the next thing is, how did we get 5? Since we said we are shifting 5 by going to 0 ID, we have shift 5. So it means we consume this ID by putting it on the stack, and also we shift 5 to our stack. That's why we have 5. So we shift 5 also to our stack. I'm wondering, probably you can't see my mouse. Let me activate some pointer. All right. So for the start, state 0 and ID. So for state 0 and ID, we have this, and that is shift 5. So we consume ID by bringing ID here, and then we shift 5 to the top of the stack. Nice. So now that we have 5 at the top of the stack, we can proceed. So what else do? We go to 5, this state 5, and then the next token, which is plus. So what does that mean? It means 5 and plus, and that is rule 6. So it tells us that now that we have on our parse stack 0 ID 5, the next thing we will do is to reduce the last ID that we just put on the stack. Please understand this. We are not moving forward to plus yet because ID has not reached the final reduction stage. So we proceed to reduce using rule 6. And if we look at ID and rule 6, it tells us that ID actually was produced by F. So wherever ID is, replace it with F. And that's what happens here. We remove ID and we replace it with F. Fine. So at this point, we are stuck because we have F, and F does not depict a state. So for us to deal with the next input token, we need a state. And that's why we do not do F and plus. The next thing we do is we are looking for how to get this 3, and that is 0F. Since you don't have a state at the top of your stack, then you go to the go-to table for the new state. So we go to 0F. 0 and F tells us 3. So it says on the top of the stack, put 3 there, and that's how we get 3 to the top of our stack. Fine. So let's clear all our annotations so we can proceed. All right. So we have 3 now on the top of the stack. We go back to the previous process. Now that we have 3 at the top of the stack, we have a token to be consumed, then we are well. So we go to state 3 and then the token to be consumed. State 3 and the token to be consumed tells us that we should make use of rule 4 again for reduction, further reduction of F. So we go to rule 4 and then we reduce F. What is rule 4? Rule 4 tells us that F actually was produced by T. So it means remove F from the system and replace it from the stack with 3. So now we have with T, I mean. Now we replace F with T. Next thing, we need a state. As usual, we go to the go-to table with 0 and T. With 0 and T. So 0 and T on the go-to table tells us that we put 2 on the top of the stack. And that's how we have 2 on the top of the stack. Fine. All right, let's move our paint again. So 0T2 now is our stack content, and we are in state 2. So again, we proceed further. 2 and plus. We check state 2 and then plus. It tells us that we should use reduce rule 2. So reduce rule 2 tells us that actually the T, which we found here, was produced by E. So that's the next thing we do. We replace T with E. Again, we find the next state by checking 0 and E on the go-to table. So 0 and E on the go-to table tells us that we are moving to state 1. So we have state 1. Fine. All right, let's continue. So what's the next thing we do? We take 1, which is state 1, and plus again to see what's going on. So state 1 and plus tells us, oh, now we are not reducing anymore. Why? Because we have reached the last state where we can reduce T2, this identifier, to E. We can't reduce further because the next rule, which is rule 1, requires us to have an addition operator and also a T. And since we don't have that, we stop here. So next thing is that we check 1 and 1 and plus tells us that we should shift 6. That we should shift state 6 to the top of the stack. Whenever we are doing a shift process, remember again, whenever we are shifting a value to the top of the stack, we are moving an input token. So what happens next is that as we shift 6, then we move this input token, which is the plus, we move it to our pass stack. So it comes to the pass stack. And the next thing, again, as usual, is that we put 6. So we shift 6 also to the top of our pass stack. Fine. So things are well. Since we have 6 and we have another identifier, so we just continue. State 6 and identifier. What do we have there? State 6 and identifier tells us we shift 5 to the top of the stack. So shifting 5 again means that we put 5 at the top of the stack after consuming another input. So we grab the next input and we move it from the from the input stack to the pass stack. And then again, as usual, we shift 5 to the top of the stack. Oops, pardon my painting. All right. So now we have 5 at the top of the stack, and then our input has been reduced to multiply ID $. So what next do we do? State 5 and then multiply operator. So state 5 and multiply operator tells us that we have to do the reduce algorithm, the reduce process. So we reduce the last token we just consumed with rule 6. So what do we have? In rule 6, we say identifier was produced by F. So where we have identifier, replace with F. And that's what just happened. We remove identifier, we replace with F. Again, we don't have a state since we have stopped at 6F. What do? We go to the lookup table, for the go-to table to get what is happening at 6F. So at 6 and F, we have the policy that we should put 3 at the top of the stack. So great, we have 3 at the top of the stack. That's the next thing. Now that we have 3 at the top of the stack, what do? We check state 3 and then star operator. So what's in state 3 and the start operator? It says we can still reduce further using rule 4. So we come to rule 4 and we reduce F to T. So we remove F and we replace it with T. Fine? All right. So let's remove our marks again. Now we've replaced F with T and we are out of state again. So we go to the go-to table at 6 and T. 6 and T gives us 9. So we put state 9 at the top of the stack. Now that we have a state, so we can check state 9 and asterisk. What happens there? State 9 and asterisk tells us that we can consume another input, and now we shift 7 to the top of the stack. So we consume asterisk. All right, let me clear the screen. Erase all ink. So we consume asterisk, and then we shift 7 to the top of the stack. Now that we have 7 at the top of the stack, life goes on. We take 7 and then we check the next identifier, the next input token. The next input token, which is ID at 7, tells us to go to state 5. after consuming the next input. So what do? We consume the next input and then go to state 5. Going to state 5 means put 5 at the top of the stack. So we put 5 at the top of the stack. Perfect. So now we have a state at the top of the stack. On the right hand side, we have an input token. Though we are not consuming this, again, please keep that in your mind. It's part of the input token, but it's not to be consumed. All right. So 5 and $sign is our next process. So we go to state 5 and then terminal $sign. So here is the intersection, R6. So now you should be familiar with what R6 does. R6 reduces ID to F. So if you look at R6 again, it reduces ID to F. So what do? We grab this guy, we kick it out, this ID, and we replace it with F. All right, let's remove our annotations again. All right, so we remove ID and we replace with F. Perfect. Next, we don't have a state. How do we get our state? We go to 7 state and F column on the go to table. So state 7 and F tells us that we have Mr. 10. So we bring Mr. 10 from here and we put on our stack. Next thing, we go to state 10 and the $sign input. State 10 and the $sign input gives us reduced by 3. So we reduce F using rule 3. So rule 3 says that we can obtain T times F from T. So what we do now is that we look for T times F and we reduce it to T. Nice. So where is T? This is T. And by the way, I think I've not reiterated this since the last time in class. Whenever we have an input token moved to the parse stack, it is moved with an accompanying state number, a state integer. So for T, its accompanying state integer is 9. For asterisk, its accompanying state integer is 7. For F, the accompanying state integer is 10. Please keep this in mind. Let me clear the screen so I can do the marking again. All right. So for T, the accompanying state integer is 9. For 0, for star, the accompanying state integer is 7. And for F, the accompanying integer is 10. So if you look closely, you realize that we have a pair. We have a pair of the token being consumed and its state. So whenever you are removing anything from the parse to replace, you are removing it with its state number. So what's next? We are replacing T from T times F. So we are replacing T times F with T. So now we have T times F. We remove all these guys. Oops, that's wrong. So T times F, and we remove all these guys and replace them with T. So we have T. All these are replaced by T. So now we don't have a state. How do we get this 9? We go again to 6 and T on the go-to table. 6 and T on the go-to table provides us with state 9. So we kick 9 to the top of our stack. Fine. So we are getting close to the end of the everything. All right, so what's next? 9 and $sign. So what's 9 and $sign? State 9 and $sign tells us now for the first time we can reduce with rule 1. So we reduce with rule 1. What's rule 1? Rule 1 says E plus T was produced by E. So we investigate again. Let's clear our markers. So we investigate again. E plus T was produced by E. So we remove all of these guys and we replace them with E. We remove everybody here and replace them with E. So we have E here. Again, we need our final state, 0 and E. We check from the go-to table. So this is 0, and we go to E on the go to table. It tells us that we should put 1 at the top of the stack, state 1. So that's how we have 1 at the top of the stack. And finally, our last step is go to state 1 and the dollar sign. State 1 and dollar sign. So state 1 at dollar sign intersects at accept. So it means our parse was successful. So on the other hand, in case during this parse process, in case during this parsing steps, you got to land somewhere here, in a place with no state, no reduce rule, nothing, no state number. In case you fall on any of such states, it means that there was a parse error and the compiler stops parsing. All right. I believe you understand now. In case you have a question, you can send me a message.